So here you can see when a question comes like no, it's again decision making under uncertainty on Excel using four methods. So what are the methods? That is the Maximin and Maximax, Laplace, and Minimax research. Here the question, you can see two variables like facility size and the possibility future demand. You have to find the best facility size for the possibility future demand. Okay. So the facility size, so I said like two variables, facility size and possibility future variable. In facility size, there are three elements, that is small, medium, and large. And possibility future demand, there are three variables, that is low, moderate, and high. All right. So we have to find out Maximin, Maximax, Laplace, and Minimax figure. It's very easy. First thing, you should have to understand the basic fundamentals of each problem, like Maximin, Minimax, and all. So have an example. I will show the solution for finding out a Maximin. Okay. So if you get a question like this, you can copy the entire question. You can just paste it here. Okay. And you can remove all the dollars. Anyway, we can understand that all the dollar signs are in terms of a value, okay, given in millions. So it will better give you a easy of doing solving your problems. So Maximin, understand what exactly Maximin. This is the theoretical part of Maximin. So Maximin is, you have to find the worst and you have to take the best from the worst. So the Maximin approach is essentially a pessimistic one because it takes into account only the worst possible outcome for each alternative. All right. So Maximin is what exactly? The worst possible payoff for each alternative, and I mean, like a worst possible payoff means we are finding out the minimum alternative from each element. Each element means small is an element, medium is an element, large is an element. So we find out the minimum from the small, medium, and large, and we will take the maximum out of that. All right. So guys, the first thing, if you get a question like this, Maximin, first you have to find the minimum. All right. First you have to find the minimum. So I'll put green first. So minimum from each row. Okay, each row, that is equal to, give a command minimum, min, click, then select all the first row, I mean all the variables or all the values in the first row, close the bracket, enter. So you got the minimum because everything is 10, every value is 10 in the first element. Okay, second is equal to min, select entire values, close. So 7 is the minimal value. Third row, min, select the entire value, close, enter. 2. Okay. So next is, so after finding out the minimal value from each element, okay, you have to find the maximum out of that. Okay, you have to find maximum out of that. I can put orange there, or red. So red means last. Okay. So we are going to find out max mini, right? Maximin. Okay. That is equal to, you have to find the maximum value from the value you have obtained. I mean, like the worst value you obtained from each element. It's equal to max. Okay, you have to give a command like this: max, select the entire column of the result you have obtained from each element. So guys, this is the maximum value from the worst. Okay, so where is 10? 10 is in which row? 10 is in smallest row. So you can select the small facility center, because we have find maximum as 10. So please map this all the yellow colors. You can map this. 10 came out from which row? The smallest row. So I mapped that. We can select maximum of this particular problem is small. You can select the facility center small, and we can write here 10, and the facility center or facility size would be small. All right. Next question is select. The second question is Maximax. It's very easy, right? You are going to take what? You are going to take the maximum value of each element first. Okay. So first you have to select the entire problem. Okay. Paste it here, same like the previous one. Remove all the dollar signs. Okay, we can do with a dollar sign also, but for the safer part and for easy of doing, I'm just removing the dollar. So what exactly we have to find? We have to find the Maximax. Okay, the Maximax. So the theory is this: for Maximax, guys, for Maximax, determine the best possible. This is not a pessimistic approach. This is the optimistic approach. The best possible payoff. Okay, it's not payoff, payoff. And choose the alternative with the payoff. The Maximax approach is an optimist. That is, go for it strategy. It does not take into account any payoff other than the best. Okay, so you can see what exactly we have to take. We have to take the first. Our method of giving command is taking the last portion as first. To find the last portion first, that is equal to max, right? Max of each variable. 10 is the maximum. Here max is 12. Here max is 16. So what is Maximax? You will take the maximum of this. The result came out from the best payoff of each element. So it's equal to max, take the maximum amount, select the outcome, enter. So map it. 16 is the answer. So where the 16 falls? 16 falls in this row. Which row? The large. So which is the best facility size? Large. For Maximax. For what? For Maximax. All right. So we can say here like 16 is the answer from this problem, and large is the best solution in Maximax. Okay. Next, we can take the Laplace. What do you mean the Laplace? Nothing. Laplace is average. The third question is find out the Laplace. So what exactly you have to do? Copy the entire question, paste it, remove all the dollar sign. One more thing, you can give $10. You can give $16. Okay. Yeah, what exactly Laplace? So this is the theoretical part. So Laplace determine the average payoff of each alternative and chose the alternative with the best alternative. That means maximize. We have to find out the maximum of the best alternative. Okay, average alternative. Okay. So that is we have to find the average of each element, each alternative. That is equal to, there is the average. No need of giving is equal to. There is a shortcut. Here you can see, we can in the home button itself, you can see a sigma. Just pull down, take the average. Okay, just click here, go to there, average. Yes. So here the average is 10. That is 30 divided by 3 is equal to 10. Let me see what is the average of a second. Wait, oh my god. Yes, 10.33 is the average. You can check. Okay. Next is average. Sorry. Average of the third alternative would be this. That is 7.33333. Okay. All right. So we have to take the best solution. Okay, we have to take the best solution. That is the theory says. That is Laplace place of this particular constraint, uncertainty, is equal to, take maximum of what? The obtained value of each alternative. See, 10.3333. Okay, 10.33. Why we have taken this decimals also? Because we need, otherwise we have to take both small and medium. So map it. 10.33 came out from the second alternative, that is medium. So we have to give the value $10.333. Okay, and the best facility is, okay, okay. Then we go with the last question. See, copy this, paste it here, take the question again. Here again you have to remove all the dollar signs. Okay, let me take the theory. So Maximax regret is what exactly? Determine the worst regret first. Determine the worst regret first for each alternative and choose the alternative with the best regret. That is maximum. We'll use maximum at the end. This approach seeks to minimize the difference between the payoff that is realized and the best payoff for each statement of nature. Okay. So what exactly we'll take? Sorry, we'll take the maximum payoff from each alternative here, and we'll take the minimum here. Okay. Before that, here we have to copy the rows and columns again. Okay, we have to remove this, all the alternatives, and we have to go with a small, you know, I mean, like a problem that is like, is equal to, we have to take the maximum value. Okay, maximum value, max. Okay, select the entire column. Okay, maximum value of entire column minus, so minus so max. Okay, taking the maximum, okay, of the entire column. Okay, entire column minus once again the second column 3. Okay, then is equal to maximum, okay, of the entire column minus the third column 6. All right, so next is equal to, same thing we can do, maximum of the entire column minus the first column, because you are in the first column, you have to find out the best maximum payoff, is equal to maximum. Okay, take the entire maximum minus your column. Okay, then that means total number of column minus the column which you are going to find, is equal to maximum. I mean, like it is not total number, sorry, it is the maximum value minus the column value. Okay, maximum minus the column value, cell value, that is 10, that is 12 minus 2 is 10. Here the maximum value is 16. 16 minus 10 is 6. 1 second, is equal to maximum minus 10 is equal to 6. Next is 4 is equal to maximum value is 16. Finding the maximum value minus the cell value is 4. Next will be 0 is equal to, that is 16 minus 16 is 0. Maximum minus the cell value 0. So we have found out the maximum of each cell. Okay, next is equal to what exactly here? Minimax. What is the second element? That is maximum. Okay, so we have to find out the maximum of each alternative. Okay, which, I mean, like obtained alternative. So that is maximum. Select this 6. Next is maximum of second row 4 is equal to maximum of third alternative, obtained alternative is 10. Next is we have to find out minimax regret. Find out the minimax regret. Okay, that is equal to find out the minimum. See, here we'll do the first element of the question, that is minimum. You have to find out the minimum of the obtained value. Okay, that is 4. So map it 4, 4, and 4 in which row? Medium. So guys, this is what exactly Minimax. So we can give the value $4 comes in medium facility size. So hope you understood.